then
Raymond, the virtual floor is yours.
thank you, Randy. And let's jump in with what problem are we trying to solve? As Andy mentioned, I'm involved in the requirements working group. We have some exciting new documents coming out that will answer a corporate advisory board call to provide some training and guidance to the community on requirements. They called out a gap in two key areas, one in managing requirements, and the other one was somehow organizing and getting our hands around verification and validation. It does exist a guide to writing requirements that's in version 3.0, and upcoming I'll describe some of the heritage of how these guides came about, but the gaps remained, and we're very close as a working group to releasing these documents for the community. Tammy Katz is our working group chair. She's been in for 2 years and I believe has another one. And then Lou Wheatcraft, also a co-chair among some others. Rick Zinni, Kevin Orr, but Lou Wheatcraft does deserve special mention as a lead author of the manual that really gives us the basis for these other guides and really helped architect the realignment. So 2 guides and 1 manual are close to being released. They will align with each other, and they will also align with the existing guide to writing requirements. So again, we'll lay out the evolution of this manual and the guides coming up. We'll also talk about terminology, context, some call it a meta model. But what you'll get from this brief, and the real takeaway, is just to understand some of it's not new vocabulary, but there's vocabulary that has certain context out in the community, as a practitioner. When I say requirements verification, I have one thing in my head, and perhaps my colleague will have a different vision. So I'm going to introduce the terminology, the standardization of calling which terms are what, and we think that's going to really reduce confusion and save time. It's all aligned with things we've seen before, including the systems V, but here we'll spend a little time on some new diagrams, all of which are in the upcoming manual and the guides. So what you see here is coming out, it'll be in the press. Also, as Andy mentioned, this video will be recorded. We'll also have some YouTube references for some previous briefs you can refer to as well. Finally, we can share what the outline of the guide is. And that's going to look like the table of contents, but it'll at least give you a taste of what's covered. And if there are suggestions, if we're missing something, feel free to reach out, email, or raymond.wolfgang@incose.net, or other ways. I'm also on LinkedIn. We're very much looking for feedback on these living documents. Now, August 18th, what is actually out there today hit the press. Obviously, we know the INCOSE Systems Engineering Handbook. Version 4 is out, version 5 is in the works. And then there's the Systems Engineering Body of Knowledge, called the CBOT. INCOSE is one of the 3 pillars of that artifact. It's online, there's quite a bit there. And those form the source of what's released by INCOSE, the Guide for Writing Requirements. Again, if I could call it Lou Wheatcraft, but also Mike Ryan, the lead authors from there. And that's been out for several years. However, we had to evolve to cover these gaps that the CAB asked us and the community asked us about, what about management and what about needs? Customer needs, at least in my own projects, perhaps in yours, they've come up where, we've met the statement of work, we've met the SAO, and then the customer is only mildly delighted because, well, that we didn't really think about the actual need of the system or product. So in developing these new documents, we really wanted to front load needs and how do we identify them? How do we even verify that it's a need? How do we validate the needs for the customer? So for even though the original desire was to have one guide for requirements management and then another one for a guide to V&V, verification validation, it became pretty clear that the areas morph into each other's lane, and but the manual describes all this. And the one caveat is that the different topics blend into each other. So this is our current approach. You'll see the guide for writing requirements is still there at the lower left. We're going to edit that and move some of the content into some of these other guides because it's just a better home. For our content back then, it just had nowhere else to live. Now, you'll also see on the far left a white paper. And while it's not in the guides, I just urge us to look at a larger context of integrated data as a core of just implementing all this work. We're going to lead with an assumption that a organization just has a handle on its data. It's all in one spot and it's integrated. Now, I realize not everyone is at that state, but as we author this, there's a standing in the wings is this concept of that's described in this white paper. The good news about this one, to wrap this up, you see at the lower right that there are other domain-specific guides that we could write from this. So if this middle bar, the needs, requirements, and V&V lifecycle manual, that's our base. We could write a security requirements guide. We could do, maybe there's something specific to rapid software development. Some of these software sprints, can be a week or two. That's a different model from maybe a more traditional aerospace environment. Now you can imagine the scene. We're at perhaps an international workshop and we were there. It was, I want to say it was IW 2019. 2020 is before COVID, and we have a group in the room. We're all contributing ideas about, okay, well, what should be in a V&V guide? What should be in a management guide? Well, pretty soon we realized everyone had slightly different vocabulary. So one of the main contributions of this manual and the guides coming up is we standardize the vocabulary. And at first glance, when I was reading the drafts, it felt a little stilted. I had in my head what I thought requirements meant and what I thought verification meant. So what we moved to is we have common terms on the left here. So we have ConOps, goals of a program, needs as well, business needs, OpsCon, operational concepts, con use. There's lots of different terms. We describe all that, but the term we're driving toward is the integrated set of needs of whatever system or product we're developing. Then requirements. We still call it the same thing, but we're caveating it by saying it's the design input requirements. So these are the statements or the models that we input to the design team and say, here, design team, do your magic. And then what comes out is the design. But for calling design, we say it's a design output requirement or specification. Think of a check print, okay? A check print for a bracket. It comes out of Creo or whatever software you use. In a way, that is a manufacturing requirement because that's passed to the manufacturing floor. They look at this and say, okay, we need to build to this print. In a way, that design is a requirement for the next stage. And the figures we're going to look at are going to explain this more. The final part, when we talk about the product or part or component or item, we call that the system or the system of interest, SOI. A system could be a transistor. It could be, again, this bracket. We're leaving it to the reader to scale it to the appropriate level. But in order to not make the guides too big or to muddy the waters too much more, we're calling it system or system of interest. And that is something that is in the hand, or it's a coded piece of software. It's an object of some sort that tests can be run against, and or it could be fed into a higher level part or system and then tested. But as we were drafting this in the editorial team, we realized that without some standardized vocabulary, ontology is a word I like to avoid, but you can call that too, then it's just hard to write a coherent set of documents that all align. Okay, we had let's see. One other thing with these guides is we tried to make them tool independent. So there are a lot of tools in my own workplace. A lot of people are excited about their own tool. I have my favorites. I'll keep those to myself. But we really tried to craft this guidance to be independent of individual tools. We might mention one or two that are ubiquitous in the community, but we really try and avoid it, particular MBSE tools. We mentioned MBSE, but we really want to focus on requirement engineering, needs elicitation, verification management, and those concepts. Now we move to the V. Okay, so the system V, I personally like the model. I think it's very helpful. I know there are others that we're moving toward, but if you can picture the V, okay, we'll go to that. And open it up. Okay, so again, here's the V. If you can see this more as a linear progression, and bear with me here, where you have needs on the upper left, and then from a time frame, I think we can agree time moves left to right, moving to requirements, then design, then test. We still keep the feedback, but our variant on this V is stretched out. You can see it here. So this is one of the main drawings, and I want to jump to this fairly quickly in the brief. This covers the same concepts of the V. It also includes the feedback, because as in any real world project, you'll jump from verification and maybe go back to the requirements because they weren't right, and there'll be a natural give and take. This diagram still provides that give and take and that feedback. So we'll move from left to right. On the top line, the main path, we start with, even just before we think about a statement of work, we'll start with needs and life cycle ideas. Even earlier than concepts of operations. And this is, what is the business need? You know, if we want to build a product, I work for a national lab here in the US. You know, what is our mission? What's our mission space? What are our corporate desires and aligning with our customer? Once we get there, then we can develop concepts of a product. And once we have those, we discuss those, we call that the integrated set of needs. Then they are transformed, just like a linear system. We transform those through engineering into design input requirements. These would be what we classically call our requirement set. Now, requirements can come from our customer. It can come maybe from our system requirements specification. So there are different levels of granularity here, different levels in the architecture. And that's really what the V does very well. If you going from top to bottom, what I really like the V for is that the top level is the system. And then going down, it's allocated and then decomposed. And then it becomes a manageable engineering endeavor. So this diagram here doesn't invalidate that. We could still have our allocation. We can still go from system to subsystem and go to different levels. Here, for me, it's easiest just to think of this at one given level. But with design input requirements, then we could transform that through our design activity to our design, calling our design output specifications. Then what's there, we start building or start coding, and we get a system of interest. Now, there are all sorts of arrows. We'll take the top one. We have to verify. And one of the concepts we're emphasizing here is we want to do validation along the way. So for instance, we have needs going from the left. our design input requirements, we'll perform a validation step and just cross-check with our needs. Are we building the right object? When we have our design, again, it's another validation step. We'll validate that against requirements, but where we want to drive is to validate that also on the needs. In my own project, we have some candidate designs and we want to show them to the customer. And my gosh, if they're telling us, oh, no, that's not what we want. The operators aren't going to like it. Well, we want to know if we're bringing them the wrong rock, to use a phrase, early on. And if we've done that before we've cut metal, boy, we've saved a lot of money. Again, once we have a built product, again, now we're talking more validation. By this, hopefully our design is pretty close, if not spot on. But then we have the more traditional validation of the built product. Now, the story might be done, but if we jump to the lower half, we have different parts that drive some of the verification. So for instance, going back to the left, if we have our needs and we create our requirements, there may be organizational requirement, policy, procedures, ways that we like to write requirements. Even if it's just something from our guide to writing requirements where we make sure there's a subject, there's a verb, it's testable, it's relevant, the level is correct, meaning that if we're at a component level, let's say another bracket, we're not telling this bracket to implement a system level function. And here's where for me, it was new at first, where we're saying we're verifying requirements. In this context, we're actually verifying the requirements themselves, the shall statements, if you use that model. Okay, almost like a quality check on requirements. It's a little more than that because there's some more engineering involved, but that's what we're calling requirements verification. And that part was new when I first approached all this. Once we have the design, we're doing the design, okay, we're going to check, does this design meet our organizational design guidance? Now, these may not be formal corporate requirements, but a lot of companies, even mid-sized ones, they have the wisdom of the group, documented best practices of particularly medical devices. The design verification is, did we actually design it correctly for our processes, and does our design meet these sometimes informal requirements that we have on design? Finishing out to the right, when we have our prints, our check prints, we're ready to build, we do a verification of, all right, are these prints aligned with there you get more into the manufacturing system. So this guidance we're writing, it doesn't speak very much to, quality control on manufacturing floor. We're assuming that that's either quality assurance or production verification, that part has either been solved or a different group is working that. But we do mention it, and we're calling that production verification. Was it built correct? Here's where things like lean processes and Six Sigma come into play. Then finally, for the system of interest, there's a final step on if there are other sort of corporate ways that tell us how to manufacture. Now, you may be listening to this and saying, gosh, this is for these large endeavors, military defense, and we wanted the guidance to cover the large endeavors as well. Of course, there'll be some tailoring to this. Some entities, they might not have much on the bottom row here. There might not be much requirement development policy. It's just you have an engineer and they've been doing it, they have some experience, and so not every piece here will be involved in every project, particularly smaller ones. Also, the software may not have every piece. I would suggest, though, for software, there's still architecture verification, and there might be policy on how do we architect software. All right. This is a lot to see. We're going to zoom in a little bit on the needs part. And I certainly expect a few questions on this in the end. So now, the point here is just, for going on, we do both. We need to emphasize system needs and then lifecycle concepts. So we're going to jump to another piece. This emphasizes both. This basically comes from, we'll do it there. The upper left, you can see that's blocked out, the needs and the requirements block. If we go down here, this is a expansion of that. And we just heard story after story of, gosh, we just lost track of the overall need. So this is why we're really front loading it. Now we break it up into life cycle concepts, and then that will feed the integrated set of needs. We're proposing, and again, not every project will do this, but we're inviting the community to consider actually performing a verification and validation on the base life cycle concepts that are driving the pain point that's causing our customer to want to purchase some solution. Okay, and you can perform validation on those, and that's where you go back. And again, this is conversation after conversation with the customer. Okay, what is the real problem? What's the mission? Are there measures of effectiveness we need to take into account? Where are the use cases? I'm working on some use cases now. And it's doing the use cases, we just find different questions about, who's really supposed to turn the system on? Or who can turn off the lighting if you have a system involving lighting. So that will actually drive design, because now we make, again, just speaking off as an example, needs might involve more user interfaces that were originally anticipated. Well, if you tell the design team, hey, we need another user interface here over in the, let's say you're designing a MRI system, and now we need more screens. Well, okay, the design team needs to know that. And you can imagine how awkward it'd be if you design this MRI and then all of a sudden the operators can't operate it and there's a big software retrofit. So now, again, there may be organizational requirements as we jump to the bottom here for defining a lifecycle concept. Or maybe there's a way that certain needs are defined. There's a template that a department or division uses. Now, many organizations won't have all this, and that's fine. Again, the point here is to just get a front end-to-end idea to the community of, hey, if we really are doing concepts, needs, requirements, these are all the entities that could be at play. Finally, on this, there are all sorts of standards that many of us are bound to. Again, I work in aerospace world. There are standards there, medical devices as well. Even those in the food and beverage industry, they're Procter & Gamble, they're developing things. There are standards and regulations as well. So the takeaway from all this is that there are ways to not only give more energy to defining what is the problem we're trying to solve with this engineering solution, what is the life cycle concept, how does it all fit in, what are the actual needs, and doing that up front can call out items, concepts that we need for the design. Maybe a user interface or human factors requirements. Maybe with looking at some of these standards, we're bound by this, in the US, there's a code of federal regulations, safety requirement. And finding all that out up front, but by doing some of this, what we would call V&V, long before there's a prototype even designed, that's kind of where we get the return on investment here. We find out things that we're going to need to know downstream. So then from this, let me go back to the other drawing. We feed into that, we get our design activity going that many of us are familiar with. create prototypes, get our system of interest, and now comes the traditional V&V. We're verifying our design input requirements. We're verifying our product was built to print, but also meets what we told it to do. And then it's a more traditional V&V approach. By the time we get there, we've done a lot of V&V along the way. And some people, if I just go back to the V, some people call that V&V done on the left side as we're going down. And in the manual and the guidance, we talk about early V&V as a concept to espouse. Okay, that is a handful. We're getting some good questions in the chat. We talked about maturity. We'll talk about maturity, similarity. We'll get to that near the end. But keep the questions going. These are good, and Andy's keep track of them. I want to get to them all here. So now, let's talk about the outline. Okay, so this is going to look like a lot of text on these slides, and we'll just basically section by section. And then what you see in this outline, I'll highlight what is in our guide to needs and requirements, which really speaks to the first half of our manual, and then our guide to V&V. That speaks more to the second half. Now, please keep in mind, there's V&V in the first guide, and then in the second guide, we talk about requirements. So we had to, as they say, split the pumpkin in half just to make it digestible. But please keep in mind that there's, as we go through these new ideas, there's flow back and forth. And all right, so the general sequence we start with needs, requirements, design, and then the product. And the guides again reflect the general outline. But all right, pardon the banners here, that's slipped up. That's me. The first half really talks about needs elicitation. And I think what the real contribution here is that we show a process on how to do this. So that then we continue with requirements development. I talk about requirements analysis, and this is more than just, looking at the statement, but, do we have completeness? And then the second half picks up with more traditional V&V. So if we have the design, how do we verify and validate the design? And then for the system itself, how do we get that product? How do we test the product? Ultimately, we still need to do product acceptance of the actual system. Customer acceptance, that part doesn't change. Now, after an introduction, we've definition concepts. We really have an extensive introduction because it's these concepts. I would submit they're the same as what we've experienced, but as we describe it, again, to make it consistent from front to back, we go through and really define what we mean by what's a business unit, what's a requirement, what's a need. Now, we feel that foundation is important. So. Then we talk a little bit about the data, how that the common data foundation is important. Also, our requirement specs are beyond just a bunch of shall statements. We have models, diagrams, and we talk about how to incorporate that. Okay, then we go into the guide to needs and requirements territory with chapter 4. You can see the italics there. And we just describe, okay, they get the concepts. How do we do concept and need definition? Then how do we do verification and validation on the needs? We continue with that guide to do the input requirements. We got how to do requirements definition, how to create the models, as well as the maybe more traditional shall statements. Then we talk about requirements verification and validation. And this is before we've built a prototype. What we have done, though, by this point is we have maybe done some system models, or maybe we have some candidate architectures, a physical architecture. And it wouldn't take much to take a physical architecture, maybe do some modeling, and then show that to the customer, saying, hey, here's our vision. We have not cut metal yet, but with the needs you've told us and our requirements as we've interpreted them, this is what a candidate design architecture would be. So, no, that it needs to be independently powered. Okay, well, that's good to know. So there, we've actually done V&V on the requirements. Again, you could save a heck of a lot of headaches downstream, finding that out. A personal challenge I've had with that, I was working on a software project, this is years ago, and our customer was excited about our work. We had a good reputation, and the temptation there, you could see it in their face, was, okay, team, just do it and let us know when you're done, and we'll deploy your software into our server room, and we'll tell the server folks, and we'll deploy. No, customer, we need to ask you tell us about your business process. And I think they were frustrated at first because all of a sudden they're paying us. Hey, we're paying you. Why are you taking all our time? We're busy. We're operational command here. And we had to make the case that the customer time was well spent, and that they didn't see it at first, but eventually, when they got a product that just really matched their need, they were delighted. This one, it was a real success story. The customer was delighted. But my manager at the time just had the savvy and said, hey, we have to know all this up front. We almost might have spent a little too much time on requirements architecting, but your customer might push back at first. And if you can just make that sale, and they give some stories about, hey, this will really help us bring the right rock the first time. And, we finished at cost and on schedule for that one. Actually, we finished a little early and under budget. So the customer was even more delighted. But it was because of that front end dialogue. Moving on, we got section 8 with the verification and validation of the design. Okay, so the design team has done their thing. They have a group of maybe prints or models, or we're pretty close to being ready to code software or cut metal. We describe that in detail. And 8 is a pretty big chapter. 9 is a little smaller. We talk about just verifying production, checking that something was built to print. Again, we refer to quality management systems. That usually covers it. But we'll leave that to the reader. We didn't want to get into that lane. But there are a lot of other documents and guidance that covers that. Then we move into one of our larger chapters, which is 10. How do you do V&V on a system? And there's, again, verification. Okay, did we build the system correctly? Does it meet our design? Does it meet the requirements? We go even back to the needs. Okay, here's our system. Is it still meeting our needs? To verify that. And then the system validation is more at the acceptance level. Okay, what was the correct system built? And there are ways to differentiate where one starts and the other starts. We discuss a little bit of that more in the manual. As you can imagine, it overlaps. So. Now, 11 is the actual process of doing this, basically verifying our system to the input requirements. When we talk about needs, especially if we talk about concepts, that's validation territory. Finally, a lot of use of off-the-shelf systems, commercial off-the-shelf, even government off-the-shelf. So we speak to that, and then what other considerations that might help us if we have a very much of a procurement supplier relationship. There, we're cutting statements of work, and maybe our group is more the integrator. Now, as you can imagine there, the key is just defining what our D&V needs are to the supplier and getting it in the contract itself. Now, we'd be amiss if we didn't mention a management process, communications, doing CM, change management, and there's a lot of interest on attributes as well. Now, For those familiar with the guide to writing requirements, we mentioned a lot of different requirement attributes in that existing guide to writing requirements. Those attributes also apply for needs, and they can be applied elsewhere. So if you haven't downloaded that, if you're a full INCOSE member, you can get access to that, the guide to writing requirements free. I encourage you to read through. That's got a lot there, and a lot you'll recognize if you then move to the manual. We talk the tool sets, but again, we try and keep it tool agnostic. And long story short, we had this call from the cab, and not just the cab, lots of people. Okay, is there a V&V guide? The Systems Engineering Handbook, that has a lot there. I've used that a bit, especially with the types of verification methods, simulation, test analysis. The handbook is great, but it's just, there's a demand just for more detail, and also a process of, okay, if I followed these steps and I kept these items in consideration, how is not cookbook, but can I at least get some help here? I'm a new systems engineer. I've been doing electrical engineering for 5 years, and they maybe the systems lead or the verification lead, get me started. Okay, so that's the need we're trying to meet. To do that, we needed to make some fairly large documents for completeness, because what we wanted, first, do no harm. So we're not trying, we don't want to confuse anyone to make things worse. We want to be complete and consistent, but also accessible. So finally, this goes without saying, very much a team effort. We had 20 different contributors, reviewers for the different guides, some on V&V, some on the needs requirements. The manual, we had people review the manual, which it was fairly large, different document leads, and then just a lot of engagement from the community, simply at International Symposium and at IWs to share their wisdom. So we're trying to release all these by January 22 by the International Workshop. Now, where it stands now, just to give a little bit of status, and while I'm discussing that, let me put the leadership up. We've submitted our manual to Tech Ops, and ideally we might be able to get that feedback by the end of September. Might be some changes there. So the guides will then come after the manual. So the manual will be released first. And the manual is where it's all contained. We're hoping for a January release, but we have to hear from Tech Ops. So the schedule's tentative, but there is a review level draft, a submission level draft of not just the manual, but both guides are also with some tech edits, they're ready to go. So we are much further along than we were even just 6 months ago. Now, if you would like to hear more detail, Lou Wheatcraft has several YouTube videos. I know, mostly Lou, but we, as a community, these slides, I believe, will be available. There's a YouTube channel for the INCOSE Requirements Working Group. We give presentations a lot. I would check these out, especially if you want more details on the diagrams, the new diagrams that we showed. There's also a bit on integrated data. And the intention is to publish this video as well. Finally, if you want to be involved in this, and what's exciting, what you get out of it is you'd be a part of just, documents that only come, in my experience, every 5 years. This is a uniquely productive period. We're very excited. It's a lot. And if you want to be involved, there's a way to join a working group. You have to log on to the INCOSE site. Reach out to me after the meeting if you need help with this. But anyone can join. Any INCOSE member can join, and you get email updates from what we're doing. We also have seminars. And then let me hand it back to Andy just for some wrap up, and then go dive into questions. Andy, if that's your choice, or we can do questions first and then wrap up here.
We'll do the questions first. So I have a question. There are many requirements management tools that currently exist. How is this INCOSE governance applied into these tools? Is it expected the software vendor or end user to effectively implement?
Let's see, we've tried to keep it tool agnostic. And just my experience is everyone has their favorite tool. The lane that we're focusing on is just how to do the engineering of requirements and then behind a product. So in a way, with the manual and the guides, one could do it all in Microsoft Office. I know there are those on this call who have now cringed and rented their clothing maybe, but it's I'm not sure about the last part, the software vendor to use or implement. I would submit that vendors could use this just in their engineering practices. Well, let me believe it that.
So we have another question. In terms of the systems engineering model, the NRVVLM, how is maturity captured within this process? You may have several iterations of design and build, like rapid prototyping failing fast, or does or can this be adopted in this instance?
Okay, so the concept there would be early V&V. So, and we're trying to encourage people almost, if you like the V model, to just have this have those early prototypes on the left side of the V. Let's see, we want to be, let's see, so the question is iterations. Certainly we can have maturity of design, absolutely. And on some level, the kind of like the V is maybe for, you can have different V's coming out of the page. Some would call it the wedge model, meaning that you have one V on prototype one, and when you get to the test on that one, that feeds the requirements of a second V. So let's see, we don't focus a lot on the iteration necessarily in this model. We're kind of laying it out. You can almost see it as one iteration, but what you could do is, as you do maturity, as you do builds, in fact, if we can go back, I'm going to blank the screen, jump to a slide, and then, oh, maybe that's not going to work. All right. So for here, we have a design output spec. We've done some validation, and we've done some verification as well. And oh, you know what? This design is not right. We forgot. I remember one story, they forgot a power switch. There was no way to turn the system on when it was out in the field. So, okay, let's go down. Let's cycle that back into an input requirement. Put an input requirement in there. Maybe even go back and insert a need, okay, into a baseline needs document. We insert a need, configuration control board and everything about shall be able to be powered on externally by the average technician. That percolates down, and now all of a sudden you've got another cycle going, another iteration, do a design update, and then if necessary, crank out another prototype. So we don't sort of highlight maturity. That would have a bunch of these drawings coming out of the page. My own head would explode if I think I saw it also. But sure, none of this invalidates basic engineering practice of, oh, we got a prototype, there are some problems, let's cycle it back in. What's new here is we'd encourage people to, hey, if something was missed, let's go back to the need. Maybe there's a need missing, and then not just add another requirement and say, okay, shall have, shall be purple, and then move on from there. So this is a living ecosystem. I hope that answers it. If not,
okay.
Let me know.
So we
yeah,
have a question.
Okay, next.
In the V diagram, why is similarity an analysis method of verification?
Let's see. I will have to poke on that. Let's see where. Let me locate it. Let's see. We going back to the system engineering handbook. They're just the traditional verification of test, inspection, demonstration, analysis. I'd have to put back to the handbook. Honestly, in my own shop, we're being asked, just in being smart with money, about, hey, you have a test proposed. Is there some kind of simulation or analysis that could also give us the same confidence, buy down the same risk? I had an old vice president who he didn't like the word analysis. He wanted to say simulate a test. And a test, as we know it, would be a physical test. Since moved on, but it was an interesting concept. Let's see, I think there's one more. Andy?
Yeah. So one here, I'll assume stakeholders have the need of the system of interest because it would fit well into their environment, i.e. they are interested in what the super system does. From this point of view, I have the impression that life cycle concepts and needs and requirements are constituents of the architecture of the super system. How accurate is such an understanding?
Oh, that's interesting. Let me read that in the chat. The stakeholders have some pain point. So they're asking for some solution, some system of interest. It always fits into some larger picture. We would call that a super system. We're at that level, we're talking about life cycle concepts, needs of the super system. I don't know if I'd call that part of the architecture of the super system. I would call it part of the ecosystem. I might suggest that term. When I think of architecture, if it's just totally my opinion, I think, okay, how it's structured, and this part is here, that part is there. But definitely life cycle concepts and the needs, they're part of the super system environment. And you know what, and that is excellent. Charles, that kind of thinking is what we're trying to drive. I'll be thinking about, no one just designs a widget in the ether. So anyhow, I would just suggest instead of architecture, ecosystem. Let's see.
I've got a question from chat here.
Great.
Would digital twin be considered as an additional system of interest? Do you see these verification methods remaining constant as we increase our use of virtualized V&V with the use of model-based engineering and digital engineering as a whole?
Okay, I'm not sure I would call the digital twin an additional SOI, but what I would call any kind of digital twin endeavor or effort, I would almost call that early verification validation, early system modeling. You've got, your digital twin. You haven't cut metal yet necessarily, and there you can do some validation there. You can show it to the customer. You can even run simulations. Matter of fact, the one MBSE tool that has a play button. You can simulate your system. You hit play, and if it crashes, then there's an architecture flaw. Most probably have that feature. Once you're in production or once you're out in the field, the digital twin is just part of the grand sum total of knowledge about that product, and then you can do, impact analyses. And for my own situation, sometimes we'll have a production flaw. And, well, we nicked the power supply. It's got this is rare, but let's say I had this big gash on the side of it. Well, it might still work as a power supply. Can we not lose, $5,000, and can we use it? All right, well, that's where you got your digital twin. You do some really rapid impact analyses there. So I'm a fan of digital twin. I would not call it its own entity unless in some rare case that's what the customer wants. Maybe that is the product. Unless that's what's being delivered, I see it as riding alongside with.
So is the manual going to cover other iterative and sequential life cycle approaches, or will it be centered on the V model?
Oh, let's see. Let me check. We don't talk a whole lot about life cycle approaches in the manual per se. And by life cycle, I mean, waterfall, or for those in the US, there's a Department of Defense life cycle process. We don't speak, it is a process and we propose it, but we And we do mention agile, how you can use these concepts for agile sprints, and how we still need requirements and validation in agile and everything. But we mentioned life cycle. Let's see, life cycle concepts. What we mean is the product life cycle, not the development life cycle concepts. Even though the life cycle we choose, whatever we're in, that might drive some of these organizational requirements or different stages. But early on, we're talking what's the life cycle of the product? How will it be used? If you're deploying software in a operations center, okay, life cycle would be, we install it, the operator uses it, and then what's our sunset process? So I hope that helps.
So we've got a question here. Considering the NRVVLM as your system of interest, what process did you follow to deliver it? Did you use the described NRVV process to create this product?
Oh, that's a great one. Let's see. There was some ad hoc involved here, to be honest. That's very good. Unfortunately, TechOps does enforce and levy a bit of process there. But you know what? If I can humbly suggest, the operational needs basically came in the form of a CAB request. And okay, requirements working group, what have you done for me lately? And here's the task for you. What do you think? So one was an assignment, and then the process started. Honestly, the process had to evolve, and our move from a more traditional, hey, how about have some authors contribute, and we'll have an editor smooth it out, and we'll release it. We evolved from there to a more systematic, let's define the vocabulary, let's define what our process is, and then add people's contributions to this framework. That basically came from a validation question of, hey, this document, is it going to meet the need of the community to have something consistent, to have something end-to-end, have something accessible? Midstream, this was probably about a year ago, we realized, man, we just can't do it the same old way we've done it. We need to overhaul the guide outline. I didn't want to go into this, and just almost start from scratch and architect it from scratch what we thought, the process should be, and then add things along. So we did a kind of a hard left turn, frankly, in our process of how all this was developed. There are people who can speak to this actually. And some people were a little ruffled. They're like, hey, what happened? I wrote my section and now it doesn't look anything like it. We hope we can earn their understanding, but we did a hard validation check and we did change our process. So,
yeah. I'll add in there as a CAB representative that the team did bring back numerous presentations to the CAB describing their progress and where they were going. So in that state they were validating with their customer. So question here, do you set it up with the customer so that you can take credit for validation at such an early stage? Or for instance, do you continuously validate, but can only say that requirement X is validated when the product is fielded?
Let's see, my experience with most customers is they just want the thing at the end on time and not be asked for too much more money. So we don't get a lot of credit up. This is just my experience. I don't think we've seen a lot of credit up front with the customer for early validation, beyond just maybe some pats on the back and, oh, hey, I'm glad we caught this. And yes, did this meeting, it took 8 hours over time, but it was worthwhile. I feel better that the end design, after they give us all this money, will be what we need. So we get some informal credibility, I think, in doing a lot of this validation. It shows them we're answering the right questions. Formally, it's more the traditional, hey, let's do acceptance at the end and go from there.
So question here, How are concepts and needs verified? Perfect ISO 15288. The purpose of the verification process is to provide objective evidence that a system or system element fulfills its specified requirements and characteristics.
Okay, so I would say, I would fill in our language, it fulfills its specified design input requirements and characteristics. It includes environments.
Yeah.
I'm sorry, what was the question part of that again, Andy?
It's how are concepts and needs verified?
Oh, okay. So there, if I go to a different, I go to here, it's going through this list on the left. Okay, we have what we think the concepts and needs are. And as the designer, sometimes the onus is on us to draft what we thought we heard at the kickoff meeting. And then how I would verify it is I would go back and say, okay, are these coherent statements? That'd be the verification part. Then how I'd validate it is, again, meeting with the customer. Hey, this is what we thought we need. Let's walk through it, statement by statement. I try and scrape what the customer had as far as concepts, ConOps, user stories. And it's just the face-to-face meeting, and then final approval by the customer on our needs document, and say, okay, we agree these are our needs, if possible. Sometimes you can't get that, but if I can at least get a verbal saying, yeah, that's the rock I want, we'll go from there.
We've got a number of other questions, but I don't think we'll have time for them. So I will capture these questions and forward them to Raymond so that he has an opportunity to get back in touch if you'd like to, or you can contact him if you'd like to talk more about your question. There are a couple of things in here that I think one of them is, are you still accepting inputs? And I think that means inputs to the guidance material. Let's see. As far as inputs, we have the input. At this point, we're in the review stage. And at this point, we're really trying to focus on a release by IW. But these are living documents. It's a very active working group. And let's see, someone brought up a question about software specific or fast cycle time specific guidance. That's something that's certainly open. We try to create a framework where individuals can just create their own guides using our framework and then release that to the community. So the substantial new inputs, we'd encourage them to start a new supplement or a new guide. Yeah. There's a question as well about accessing the join the requirements working group button and someone not seeing it. Just to advise, if you're an associate member, you can't get access to the working groups. If you're a regular member, you should. So that might be the difference between seeing that button and not seeing it. Okay, can you go back to the ending slides, please?
Very much so. All right, pardon the, there you go.
That one, yes, thanks. So thank you, Raymond, for a great presentation. And thank you to the audience for your questions and your time. This next slide shows our upcoming schedule. The next webinar will be held on Wednesday, the 15th of September, 2021, when Rick Dove will give a presentation on Agile Systems Engineering Processes 204, Agile Systems Engineering Lifecycle Model. Additional webinars will be offered typically on the third Wednesday of each month through 2021. If you're interested in presenting an INCOSE webinar, please let John Clark know. John schedules the TechOps webinars. Please note that if you go to the website shown here, you'll see more information about the webinar series, including a way to view the last 151 webinars and soon this webinar as well. Now, I forgot to send you an update of the slide pack, and there would have been a slide next saying, here's something new. The German chapter of INCOSE, GFSE, is launching a new global webinar series starting on Wednesday, the 8th of September. when Eljo Port will present on RCDA Agile Architecture, making big engineering decisions with Agile teams. Then on Wednesday, the 5th of October, Dr. Maximilian Juncker and Dr. Wolfgang Bohm will present on SysML Workbench for the software platform for embedded systems methodology. You go to the next slide, please. So the 2021 INCOSE Western States Regional Conference will be held in San Diego from 17th to 20th of September 2021. This slide shows the website you can register to attend the webinar. It's currently in debate whether that will be a face-to-face and hybrid or virtual, depending upon the situation with COVID. But at the moment, it's still listed as being a face-to-face. Next slide, please. As mentioned earlier, you can now claim 1 PDU credit towards your systems engineering professional recertification by attending this webinar. You may also claim this credit retrospectively for INCOSE webinars that you have attended and where attendance meets the qualification requirements. Next slide, please. I'd like again to express thanks to Lockheed Martin Corporation for sponsoring the 2021 INCOSE webinar program. Thank you again, and goodbye.